Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 12 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the graph of a quadratic parent function f, which we don't even really know what that is, but we're going to see g of x here, and we've got this right here. So the x plus 2 and then minus 5. So we've got two different things happening here. So let's just take a look at them one at a time. So we've got the g of x equals, let's just deal with it, f of x plus 2. So what happens when we add something to the addend to the f of x before it actually gets squared? Okay, so it's still going to be squared, but you're adding something to the x, either adding or subtracting, before it gets squared. This actually, when we're adding that transformation in right there, it actually is a horizontal shift. So when you're adding it before it gets squared within the parentheses, it's actually going to shift horizontally, but it's interesting because it's going to be a little bit that opposite of what we think it should be. Okay, so it's counterintuitive. So when you have this, so let's call that f of x plus d. Okay, so let's say when your d is greater than 0, 1, 2, 3, 4, 5. In this case, it's plus 2. You actually shift it over to the left. You would think, since it's positive, you shift it over to the right, but you actually shift it over to the left. When your d is less than 0, negative 1, negative 2, negative 3, that's when you shift over to the right. So that seems a little bit strange. Since we have a positive 2, right, we're looking to shift over to the left. So I see that's got to the left. This shifted over to the right, which is not what we're looking for. This shifted over to the left, and then this shifted over to the right. All right, so 2 went to the left, 2 went to the right. We're looking for the ones that shifted to the left. Now, in addition to that, we've got this f of x minus 5. So we've dealt with this. It's going to shift it over to the left. What do we do with this minus 5 that's sitting right up here? Let's deal with that separately. Well, what this does is this is a vertical shift. So this shifts your vertex up or down. And so let's look at it as g of x equals f of x. And then let's call that plus c. So if this c is greater than 0, 1, 2, 3, 4, 5, this is where it shifts the way you would want it to. It shifts it up. If c is less than 0, in this case it's negative 5, so it's less than 0, it's going to shift it down. So that's where you have to keep your vertical shifts are up and down like you would expect with a positive and negative. Your horizontal shifts are going to be left and right, but opposite of what you would think. So since we've got a negative 5 here, looks like it's going to shift down 5. And you see this one right here, this f, this actually shifted up 5. This g shifted down 5, but it went the wrong direction. So I'm thinking it's going to be this h, because it shifted to the left because of the plus 2. And then it shifted down with a negative 5, knowing that that plus 2 is opposite of what it should be. So let's plug this into the graphing calculator to double check. So if our parent function is simply x squared, then we will plot this x, and that's going to be a plus 2. Then we're going to square it, and then we're going to still minus 5. And let's see what it looks like when we graph both of those. So the blue one is your parent function, and yep, that red one, it shifted over to the left 2 and it went down 5. So that is going to be our answer. The answer is going to be H.